Okay, so once again, we're given an angle and two sides, and the angle is not between the two sides. So before I try to solve any of the triangles, I need to determine whether or not this actually even makes a triangle. So I'm going to start by drawing a little diagram here. About like this. I'll put the angle that they give me over here on this side. It is acute, so I can't just look at whether or not the side across from it is longer or shorter. The side across from it is side A, so that's a 12, and the side next to it is side B, which is 15. Okay, so if the side across from the angle that was given was longer than the one that's next to it, then it makes exactly one triangle, but this time it's shorter. So that means we're going to have to figure out the height of this triangle so we can determine whether this makes a triangle at all. So once again, the height of the triangle is found using right triangle trigonometry. The side that I'm given, if I turn this into a little right triangle there, the side that I'm given is the hypotenuse of that triangle, and the side that I'm looking for, the height, would be opposite that angle. So that would be a sine, opposite and hypotenuse. So that would be h is 15 sine of 20.5 degrees. Okay, and then I would need to type that in my calculator so I can find out if it is greater than 12 or less than 12. So I put that in my calculator and I get that the height of this triangle is approximately 5.25. Now, since this side over here is 12, that means it's definitely long enough to make it all the way to the other side. So it will definitely make it over here, as the shortest distance is 5.25. If it were less than 5.25, it wouldn't be long enough to make it to the bottom, even if I went directly there. Now that also means that I could make this triangle by putting this side back this direction here. So this one is actually two triangles. And because it's two triangles, that means I have to solve both of them. Okay, so I'm going to start off with the first triangle. I'm going to use my tools over here to draw a picture of it. For the first triangle, I'm going to draw the one that is oh, this is saying it's isosceles. I don't want that. Okay, I guess that's all that I had available. So I'll just use lines. So here's the bottom of my triangle. Here is side B, and this one is going to be side A. So this is for the first triangle, the outer triangle that I drew over there. And I'll label what I know. I know, whoops, wrong color. I know this side over here is this angle is 20.5 degrees. This angle is A. The side across from it is 12. The side next to it is 15. That was messy. I'm going to try again. There we go. So this side is 15 and it was side B. So that means the angle across from it is angle B. And that means the last angle up here would have to be angle C. And at the bottom we would have side length C. Now because I have two triangles on this one, and they're both going to use the same given information, that means I'm actually going to have two sets of information for the three unknown values on this triangle. So for this first one, I'm going to call it B sub 1, C sub 1, and little c sub 1. So when I find these, I'll label them with those subscripts on them to determine that that's my first triangle. Then when I find the second set, I'll put a subscript of 2 on them. All right, so to find this one, I'm going to be using law of sines like I did before. I have to have a side and an angle that are related to start with, and I do. I have side A and angle A, so I'm going to start with that. 12 over sine of 20.5 degrees. Now for the law of sines, in order to use it, I have to have another pair where I know either the side or the angle. And the only other side that I know on this one is B, so I would have to use 15 over sine of B1. Okay, now once again, since I'm solving for the angle B1 and it's in the denominator right now, I'm going to use that trick where I flip both sides of, flip both of the fractions just to make it a little bit easier. There we go. Okay, so my first move to solve this would be to multiply both sides by 15. I'm going to cheat a little bit and make this easier on myself. And then my next maneuver would be to take the inverse sine of both sides. So when I do that on the right, the inverse sine of B1 would be just B1. And when I take the inverse sine of the left side, it would just be the inverse sine of all of that lovely stuff over there. Which takes a really long time to write with this pencil. There we go. Okay, so from here, to get an approximation, I would need to type that in my calculator. And so I put that in my calculator, and I get 25.961. That is an angle, so that's going to be degrees. That is one of my answers. And once again, I encourage you to take a moment and actually type this thing into whatever calculator you're using to make sure you're getting the correct answer there. All right, so now that I've got angle B1, the only things left to find are angle C1 and side C1 for the first triangle. Since those are related sides, related angle and side, I can't just go straight into the law of sine, so I'm going to have to use the fact that the sum of the angles of the triangle are 180 degrees to find C1. So I've got 180 degrees minus, and then the sum of the two angles that I do know. There we go. Oh, and one of those is approximated, so this really should say approximately equal to. And then I'll pop that in my calculator, and I got 133.539 degrees. So now I have all three angles for this first triangle. The only thing I have left to find is little c1, side c1. So now I'm ready to use the law of sines again. I'm going to change colors. So I'm going to start with the side and the angle that I know. So 12 over sine of 20.5 degrees equals. And I'm looking for a side little c1. So that would be over sine of angle C1, which is the one I just found, 133.539 degrees. Okay, so to solve this one, I would be multiplying both sides of this thing by sine of 133.539. And, well, once again, I used an approximated value in there, so this really ought to say approximately equal to. So I'd be typing in my calculator 12 times sine of 133.539 degrees divided by sine of 20.5. And when I do that, I get 24.839. Okay, so now I have all three pieces of missing information for my first triangle. But now I have another triangle to solve. I've got this obtuse one. So let me sketch a picture of that one. So I'm going to sketch it over here. My side A on this one is going to be very small. I can see from my original sketch there. Side length, that's not A, that's C. My side B looks just like it did on the original one. And then this side over here would slant backwards. So now I'm going to label everything that I can over here. This is angle A, which is 20.5 degrees. That's going to be hard to see. The angle up top is going to be my C. This is my second C angle, so I'm going to call it C2. The one down here is B2. The side across from A is still side A, which was given information, so that's still 12. And the side across from B2 is still my given information, so that's still 15. And so this side down here on the bottom is little c2. So the things I need to find on this one are angle B2, angle C2, and side C2. Okay, for this one, the first piece of information I'm going to find is actually B2. I'm going to do a little magic to make this happen here. I'm going to illuminate for you what I see. So if I were to draw the other triangle on top of this one here, you would see that this little triangle on the inside here, this one right here, is actually an isosceles triangle, which means that those two sides are congruent, which also means that these two angles are congruent. I needed to change that back to a pencil. So these two angles here are congruent. Now, what that tells me is that I can actually use that information to find this angle over here. Because if I know that one, which I do, that was B1, then B2 is just going to be its supplement, which would be 180 degrees minus whatever B1 was. Now I'm going to use an approximation symbol on this one also because B1 was an approximated value. I'm going to put that in my calculator to get the value of B2. And so that one turns out to be 154.039 degrees. Okay, so I have my first piece of information for my second triangle already. The next thing I would need to find is C. So C2. And in order to find C2, I'm going to use approximated also because I have to use approximated values here. So this would be 180 degrees minus the two known angles in that triangle. So that would be 20.5, my given value, plus B2, which is 154.039 degrees. And then I'll pop that in my calculator to find out what that is approximately. And I get 5.461 degrees. Okay, so now I've got 2 of the 3 pieces of missing information from my second triangle. I just have one more piece to go. Okay, so the last piece is side C2. So to find that, I'm going to use law of sines, and I'm going to start with my given side and angle that are related. So 12 over sine of 20.5 degrees equals, and then side on top here, so C2 over sine of, and I need angle C2, which we found was approximately 5.461 degrees. And so once again, we have an approximated value there, so I should have approximately equal to on this. So now I'm going to solve this one for C2. I would do that by multiplying both sides by sine of 5.461. I'm going to type that in my calculator. That gives me 3.261 for that last side there. And so now I have the third piece of missing information for the second triangle. So in this one here, when there are 2 triangles and they give me 3 pieces of information about the possible triangles there. That means I'm actually going to have 6 answers total. And I need to make sure I have those subscripts on them so that I can differentiate between the first triangle and the second triangle. Now, the big key to making this work is, of course, having this bit of information right here. Once you've solved your first triangle, your second triangle, that you'll find an angle first, that B2 angle, and it's always going to be the supplement of B1. Okay, now answer the next couple of questions on the Google form, and then there is an attached practice assignment. You should do as many of those as you feel like you need to in order to fully grasp what's going on here.